Hey folks, today I have the pleasure to host for the very first time Reizu. He's a director PM at Databricks. Hi Ray.
Hey, Joseph, thanks for having me here.
I'm really excited to have you here, and I don't want to spoil people, but I'll let you introduce yourself and maybe tell us on which product you're focused.
Awesome. Hey, folks, I'm Ray. I'm on the product team at Databricks, primarily focused on data engineering and specifically declarative pipelines is something that I spend a lot of time and attention on. Before Databricks, I spent a long time, almost 8 years at AWS from the very early days of cloud, and my focus there was on Kinesis, stream data processing. So you can see the relationship with why I'm driving declarative pipelines. So that's me.
So I think you guessed we're gonna be talking about DLT, Flow Declarative Pipeline, and well, the new name is Spark Declarative Pipeline, SDP.
That's right. It's a forever joke of how we change these names, but it's Spark Declarative Pipelines.
So can you guarantee this is the last rebranding?
Personally, I want to do that. I can, but I can't guarantee that. But I hope that is true.
Well, for those who may miss the news, SDP has been open sourced and you can now try it as part of Spark 4.1. You can deploy it locally and start building on your IDE, I don't know, VS Code, and deploy your pipeline just to get started. And I think this is something that where Databricks invested a lot to make sure that we still embrace the open source technologies.
Yeah, that's not true. And by the way, that's actually something we always wanted to do because, you know, as you said, like the root of Databricks is about open source, right? We build open source frameworks, we drive community adoption, and we offer something for enterprises and commercialization with better performance, production support as a company. So when we invented declarative pipeline a few years back, which was called DOT, as you said. So that was always a plan. It's just in the early days, we didn't have enough staff to really do the open source push. And also there was a lot of demand on the product. So we focused a lot of their resources on really making the product great. And now we're at a point where we see a lot of adoption. We have strong conviction on that vision and the future. In fact, we want all of the data engineering workloads to start to move from the data frame API into the declarative pipeline APIs. So now we feel like, you know, the time is right. We should spend the energy, spend the resource, give the framework into the communities. And we would love everybody to pick up that framework, and all the different vendors, platforms should embrace declarative pipelines as a new paradigm. And we're very excited about that.
Yeah, and I remember I interviewed Michael in February, and he said at some point we're gonna open source DLT. We just need to make sure that everything works fine. And yeah, and in June it was announced, and it was really great news. I'm pretty sure we're gonna see a huge adoption, and it will also help tools. I don't know, Cloud Code, the Genie code now to write pipelines, and this is something new. You can use Genie code to write your pipeline quickly with platform.
That's actually a very good point, by the way, like on, things, it's the era of agents. So we can talk about that. So the fascinating fact is that, obviously when we invented declarative pipelines back in the days, Gen AI wasn't quite a thing yet. But the idea of it is actually very simple, which is abstraction, right? If you look at technological advance, this abstraction happens everywhere. And the core principle of abstraction, or the value of it, is that it makes easier for humans to develop and maintain, to reason about, so that you can use the system in a much easier way. Think of SQL, which was a declarative abstraction language to process data. And but the fascinating thing is that actually agents likes abstraction too. I don't know if you've tried to, interact with the systems. Actually, agents works extremely well with command line tools like CLIs. But if you think about CLIs, it's abstraction, right? With that somewhat restrictive but more principled interface, agent can do much better job reason about things. So I think with that, that's another reason, by the way, why we think declarative pipeline should be the new norm, the new de facto for data pipelines. Is not it makes things easy for the humans, but actually it makes it much easier for the agents to author these pipelines, reason about the pipelines, and write good quality code and be able to debug the pipelines under this sort of more declarative interface. I certainly didn't see that coming as one of the reasons, but I think, coincidentally, things make it easy for human. Also now it's prime for the agents.
During the last couple of months, a lot of enhancement has been added. Now you have the possibility to copy tables from apply pipeline to, for example, another pipeline. You can, I think, more recently announce the possibility to change the system source without having to run a full recompute in case you're changing the source system, if I'm not wrong. The optimizations are done with the PO, predictive optimization. I'm talking about the vacuum, the compaction. You can use liquid clustering within your MVs and STs. We have more features on the observability side with the Lakeflow, with the dashboards that you can deploy
That's
and
right.
see. Like, so is there anything I missed, and where are we going with this with the SDP?
Yeah, so that's great. So I think the way I think about the pipeline product in terms of like data engineering workloads and in terms of like declarative framework, essentially you have two layers of declarative value propositions. One is at the query layer. So before you have a data pipeline, you have these break it down into each individual queries. And what people care about queries is almost always in data engineering is I want incremental processing, incremental computation, and I want a lower latency in a sense that you don't want to reprocess the data that's already there. And at the query level, there are two different processing semantics. There's streaming semantics and there's batch semantics. And streaming by definition is incremental, right? Because streaming semantics basically means that you keep looking at the source and you process new data as they show up. So by definition, you only look at new data. Where batch, by definition, you look at the entirety of the data in the source, and that's why we have, a technology you've probably heard of called Enzyme behind the Materialized View, constructing the declarative pipeline that handles that incremental computation for you automatically. Now, the truth is that human brains still like much better at reason about batch because data is finite compared to streaming, which is why I think, although streaming is really taken off for very simple workloads on the ingestion side of things, in the transformation line, I still see that, most of the workloads will leverage batch semantics, but Enzyme really makes it simple to handle the incremental processing for you. So that's the first layer, right? Which is at the query level. So there's a lot of innovation done in the query level, right? So we have a auto CDC API on the streaming side of the query makes things very easy to do type 1, type 2 tables. There's a lot more innovations happening over there. For example, we have this new API that just GA allow you to, in cases when you don't have the change feeds upstream, let's say your upstream database team, they only give you the snapshot. Now we allow you to do type 1, type 2 from the sequence of snapshots. Very soon we're going to allow you to mix the snapshot with the change feeds. So you can throw snapshot or change feeds at the same type 1, type 2 table. We're going to handle all the order and logic behind the scenes for you. Then in the batch land, we have materialized views, right? Which is, again, like it's very, go ahead.
No, I think it is worth mentioning that with auto CDC can be done with 5 or 6 lines of, while if you wanted to implement such a solution, you would need at least maybe 200 or even more. So it makes things way easier for you.
100%. And by the way, that's, among one of the most popular features inside the Declarative Pipeline. And we actually plan to deploy that capability across the Databricks platform, including DB SQL Data Warehouse, including the notebook product, so they can use a very simple single statement with a few lines of code to do that. They come back on the Materialized View side. People love Enzyme. And Materialized View actually guarantees the accuracy of the data based on the source table. So a lot of people use Materialized Views for like the gold, platinum layer and for query acceleration dashboard. We're actually adding a new capability, which is coming very soon, which is what we call replace where. So instead of refreshing the entire table to guarantee accuracy, we allow the users to pass a predicate. Things like, I only want to refresh today's data, or I only want to refresh the data from this particular region, from this particular partition. And within that predicate, actually Enzyme will kick in to do the incrementalization techniques. So personally, I think that'll be a very popular primitive for people to do large scale ETL in the bronze to silver layer. Compared to ND, people will continue to use that for dashboarding and query acceleration. So that's, there's a lot of innovation happening at the query level. And I kind of, teed up a little bit on the fact that we're going to give a lot of these query level innovations into, the rest of the product stack we have at Databricks so that all these different users can take advantage of them. Then the second layer, which is one layer up, right? You have these individual queries. But for data pipelines, it's not a single query. It's a sum of multiple queries. And that's when declarative comes in. Similarly, there's values for streaming, there's values for batch. For batch, it's kind of obvious in a sense that, now system figures out which queries to be run in what order. So you don't need to manually think about, I should run this table, then that table, then update that table. It infers that order and runs that declarative orchestration for you. And that's what a pipeline does. Pipeline allows you to, put a bunch of these different streaming and batch queries inside it. It'll figure out the orchestration order for you. Then on the streaming side of things, orchestration kind of no longer really matter, right? Because for continuous streaming, all the queries just keeps running. Like there's no order in terms of what to run before what. But if you think about continuous streaming workloads, what matters is really availability, right? The fact that you're running continuously, either it's mission critical or you require low latency on your business use cases. So you don't want the pipeline to be down, whether it's for your deployment, change your code, or runtime upgrades. And the fact that we have the pipeline orchestration functionality for continuous streaming means we understand the data flow graph of how things are being run. So we can do interesting things like you can, if you want to, update your code, we have now new business logic. Instead of redeploying the entire DAG, the entire pipeline, we can keep everything else running as is, and you just redeploy one specific query. And in case of like runtime upgrades, we can warm up a new runtime, a new cluster with that entire DAG and stay preloaded and just do a flip. I think in certain cases, people call it blue-green deployment. You can flip that to guarantee maximum flexibility. So that's the second layer, which is the pipeline DAG layer for both batch and streaming. Pipelines give you sort of these specific value propositions. So I guess my point to sum it up, the way to think about the declarative pipeline product is that there's query level innovations, value propositions to the data engineers. There's streaming, there's batch, and then there's a DAG layer, which is a data graph layer. That's what a pipeline gives you. Again, it applies to both streaming and batch. And when you sum it up, that's what declarative pipeline is. And, cater towards both batch and streaming processing for data pipelines.
And even the ID, the dev experience has been massively improved. Like the new UI is insane. I think it's even much better than the regular environment you will use to write your PySpark. You have the tree where you can define maybe your bronze, your silver layer, and gold layer. You can also add maybe unit testing, and it can be automated, like writing unit testing on the top of your pipeline. You can define the dabs, the asset bundles directly in the workspace. Then you can write your code, and once you can run the dry run just to make sure that you have no error syntax. And what's cool, when you run run your pipeline, you can see the DAG being built in front of you. You can see every single table being populated, and the system and the lineage being created in front of you. And then you can click on each table. You can view the sample. This is something we couldn't do in the past. We can view the sample of the data. We can view the data quality. We can do a partial refresh rather than doing, I don't know, I just updated a base table at the end to enrich my customer data. I changed just this customer data. Maybe, for example, with new addresses, I will just select those two tables to refresh just the two last components rather than having to refresh the entire pipeline.
That's right.
I think the new experience is just insane. So people just need to give it a try. I think it is worth. You need to forget about the DLT experience. Try it. You're going to really love it. And now use the SDP, embrace the SDP experience.
Yeah. So I think you made a good point. By the way, the selective refresh capability you mentioned is because of the very fact that that's the data graph level declarative paradigm, which is for the fact that we understand the data graph, so the system can do these things for you, as opposed to it's a black box. You have to restart everything. But I think, Joseph, you made a good point, which is apart from these core engine innovations I just mentioned, it's super important for us to provide a solid dev experience, like the IDE you mentioned, where, and by the way, you should try it out if you've tried it before. It runs very, very fast, gives you the DAG, it gives you the observability, so you have everything in one interface. That you can build your data pipelines with visual. And also, I don't know if you guys have heard about it, that we have this Lakeflow Designer product, which infuses AI to give you that visual feedback loop and build these pipelines for you. We also have now data engineering agents. So if you pop into that editor that Joseph you were talking about, on the right panel where we have that Genie code from Databricks, you can actually talk to it and it'll write declarative pipeline code for you. So I think about it, that's another piece where, with Gen AI, I think a lot of that development loop user interface will be revolutionized, make it even more productive. I think that because the very fact that declarative pipeline with that abstraction interface will make that experience much smoother compared to generic coding experience. So that's one on the dev side. Then on the other side, which is observability, right? For all the data engineers out there, you kind of know, I don't know you probably spend less time on writing code versus make the pipeline, just keep running, right? Because the schemas might change, business requirements change, you need to backfill the data, things arrive late, you have to deal with all that stuff. An observability experience with system tables, event logs, and UI, run history, these are absolutely critical. And in my opinion, by the way, that's another area where agent can play a huge role. The very fact that, declarative pipelines, we have jobs for productionization, we have UC, Unity catalog, store the lineage information. I think with all that data, it makes very straightforward for the agent to reason about when your pipeline fails or have warnings, like what is going on, and give you recommendations. So that's another area actually we're looking at very, very closely, which I'm very excited by. I think, because of declarative nature, the agents can fundamentally change how people develop their pipelines and how people maintain and keep their pipeline up and running. But stay tuned. I don't want to spoil it, but we'll probably have something to show you at the Data and AI Summit this year.
Yeah, and I think you mentioned something very important about Genie code. Why should I use Genie code over, I don't know, Cloud Code or OpenAI Codex? Well, with Unity Catalog, we have the metadata, we have the context, which means when you write the code, it automatically understands which sources are we using. And when I'm developing my script, if I have an error, I don't need to copy paste the error in the another tab to make sure that I fix the issue within the Genie code. I can automatically click on debug the error and it will trigger. Same thing, if I want to use SDP, well, the Genie code already integrate the data engineering agent, which understand and knows the system or like the syntax in order to write SDP, whether using Python code, Python or SQL. And on the top of what Ray mentioned, we have the observability. So all the logs, everything happening inside the SDP are stored in, you can define the data table where those logs are stored, and then you can build an AI BI dashboard. You can also use Genie code. Genie code asks the authoring agent that will create a dashboard using those logs, and then you'll be able to monitor Databricks, to monitor SDP with Databricks, and you can have this full observability plus the other dashboard to track the cost.
Yeah, I think that's spot on. In fact, under the hood, it's all running. Everybody's all running the same foundational models. I think really the key is that the contextual, the two things. One is the contextual information, as you mentioned. It understands the system with the context, with all the metadata and information in Unity catalog and observability. Then the second aspect is the native part of integration. The fact that you can make it super easy, like you can write a code, you can debug, you can fix it, you can rerun, take me to the observability, like all that coherent experience that we provide. In fact, actually, by the other thing I kind of want to mention is that we actually developed a lot of the skills to make the model being able to write pipeline code very, very easy. We're going to, if not already, don't know the specific pipeline, but we plan to make all of these skills available for the entire community. So even if you're not using the Databricks IDE, even if you're using Cursor or Cloud, all these things, you will have these skills to be able to easily to build pipelines. But again, if you use Genie code, you can get a much more native experience, but we also want all the other IDEs to be able to easily build these pipelines with the skills we've built.
Yeah, and I think if I'm not wrong, even Databricks is relying a lot on SDP. For example, if you have a delta table and you want to create a Lakebase, like the sync tables are using behind the scenes SDP.
That's right. Yeah,
Vector
because of the very
search,
fact
if I'm not wrong, is you also
vector
using
search.
SDP.
Yeah, and if you look at the materialized view capabilities in the data warehouse, and very soon we're going to add more, like as I said, auto CDC, replace where with Enzyme incremental localization engine enabled. All that stuff is running SDP behind the scenes. The way we sort of look at it is that, before AI, now with AI even more so, data flow workloads is sort of ubiquitous, right? No matter what you do, you need the data. You need to process data, you need to move the data. And the fundamental primitive is actually the same, right? I'll give you another example in a case that in our AI BI dashboard, we actually created materialized views behind the scenes to cache and, for better performance, which is why I think, the fundamentals of as I mentioned, the first query layer, whether it's streaming, whether it's batch, that incremental processing that's offered by Declarative Pipeline is ubiquitous. I can see that being used across the board for AI applications, for data applications, and internally is powering a lot of our own products.
And I think also lately you release like the compatibility mode. And I think these features can also be very, very helpful for those who can read streaming tables or MVs outside Databricks. Like compatibility mode can be very helpful because it will create a delta table that can be read using any delta forgot the reader and writer.
Iceberg?
No,
Yeah.
like delta reader and writer, like client, any delta client. That's why I was looking for the word client, any delta client.
So Iceberg client, not only Delta,
Or
but also Iceberg client. Yes,
Iceberg
I
client.
can I can explain why about the compatibility. It's kind of back to the fact that, we're open company. Our root is in open source and not only about the processing engine, but also on table formats. We want the table formats to be open. We want all the engines to be able to interoperate on the same data sets across the board. But the very fact is there's, one catch to that, which is at the same time for our managed table and materialized views, I think you talked about some of the things on like, predictive optimization and liquid clustering. And for materialized views, we do this incrementalization under the hood, which means that it requires the system to manipulate the data in certain ways to be able to do these optimization layout on read and write performance for the readers. But the very fact is that then you require the reader to be able to process these unique information so that, the users still get the data they want, which is why we spend a lot of time to work on this compatibility mode. And there are actually two. So you can either do the plain compatibility mode, which will create a new plain Parquet file for readers that absolutely cannot understand modern protocols. But for any new modern readers, whether it's Iceberg or Delta client or readers, we just released a feature that allows you to read all of the managed tables, including materialized views, without a clone of the raw Parquet file. So basically with that, we give the users, the customers, the best of the two worlds. One is like all of the table is optimized, incremental processing, good for read, good for write performance. But at the same time, you still get that interoperability and open access to the table. That's the spirit of a core of the compatibility. There was a lot of I was involved in that. There was a lot of technical challenges to give people both of the worlds, but we did it. The team pulled it off. So I'm very excited.
I think you've summarized everything. So I think the only thing that I'm missing right now is an SDP swag.
You have a Unity catalog one. We'll figure out one. We'll get you SDP swag for sure.
That
actually, our swag was still on BLT. Sorry, the final naming joke.
Thank you so much, Ray. It was very interesting. Thank you so much. And for those who want to know everything about SDP, make sure to register for the online, for those who can't go to San Francisco, to register for the online Data and AI Summit experience. You would be able to view the conferences or a little broadcast. And you can also later have access to all the sessions that will be uploaded to the Data and AI Summit website.
Awesome. That's great. Thanks for having me here, Yosef. It was great chatting with you.
Likewise.
Awesome. See you, man.
In Lake Cow. Drives data seas, lake flow, streams the flow. Iceberg and Delta Lake, tables aglow. Unity catalog governs Lakebase, OLT base strong. Genie, texture, SQL, mosaic, and KI prolongs. Yusuf and Quick.